Okay, so hi everyone. I'll be going through some of the questions for reading assessment 2 in 21-22 paper. However, instead of going through all individual questions, I will just be showing how the program is evaluated so that afterwards you'll be able to understand the remaining questions. Okay, so let's see program A. Program A here, in my program environment, I will have a function foo, and this function itself will take in two lists, that is xs and also ys. Okay, so since this is a function, hence I will create a function object here, and the body, of course. Okay, now this function foo is as it is. And now we will see for AA, BB, and CC. AA will be a list of 1 and list of 3. So something like this. Okay, this is my AA, and then my BB is basically the list of 3. Then I will have a list of 4. Okay, this will be my BB. Then now I will have my CC. My CC is basically the result of applying foo to AA and BB. Now let us investigate foo. When I call foo AABB, okay, when I call this thing, I will have a new frame where my axis will basically be my AA and my YS would be my BB. So my axis should point to here, this whole thing, and then my YS should point here. Afterwards, since this is not null, right? So I will have to evaluate the else block. And in my else block, I will have a constant which this constant which will be dependent on the result of applying foo to the tail of xs and ys. Okay. So now I will move on to foo of tail xs and ys. So this foo will basically have another frame extending. And in here I will have xs now as the tail of AA. That will be somewhere here. Then my ys will just be my BB. Okay. Then my wish now will again call it on the tail. Okay, so something like here. Then I will have to create another frame for foo. But this time now my axis will be the tail of the tail here, which is my null. So in this case, I will need to put my null as a primitive value, whereas my ys would still point to BB. Okay, since the ys is still the same. Now in this case, right, if I already have this thing, I will return map x to itself and ys. So what do I return? Logically speaking, you might be thinking that I'm gonna return just this whole thing, right? Which is my BB. The problem is, returning ys is not the same as returning map x to itself of ys. These are two different things, and that's the basic point of this question. Okay, so returning ys is different from returning map identity function to ys. So what happens when I return map identity function to ys? When I return this thing, map, right? Map basically creates a new pair with all the elements of ys. Okay, so now I'm gonna create a new pair since it maps to itself. So the head will map to the head of the original one, then something like this. This is basically the result of applying my map function with the arguments of identity function and also my ys. Okay, so this is the result. I have something like this. Okay, and this would be the thing that I'm returning in this frame. I return this whole thing. So when I return this whole thing, my wish now becomes this. My wish now will refer to this new list that I created, and hence I'm now here. So I need to set the tail of my access. My access now still refers to this part, so I'm gonna set the tail of here to my wish. So this now, I will set the tail to this wish. Okay, or rather I think it's a bit hard to see here, so I'm just gonna use this way. So this is my result after set tail, and then I'm returning this whole access. So now my wish in my left side here, my wish now will be referring to here. Okay, this will now be my wish. And once I have this wish, I just need to set the tail of my access, which is the head part here. I just need to set this tail to my wish. That's basically setting this whole thing. Afterwards, I'm returning this thing. Okay? And once I return this, now this will be set as my CC. So now my CC will be pointing to this whole thing. Okay? By now you will see that if I will just duplicate this page, if it's possible. I don't think it's possible, but anyways, you will see that your AA now, AA will start from here, PB will start from here, CC will start from here. Okay, and you can now answer the questions from there. One of the trick questions is basically for the part where it's equal sign. Now the thing is, one of the questions is const CC2 is tail of CC. Tail of CC will mean that it will refer to the tail of the tail. That means it will refer to here. But then your BB is referring to this one. Are they the same object? No. Since they are not the same object, so when you call the triple equal sign, they should return false. However, if you call the head equals to this head, since they are referring to the same object, your list of 3, and in this case, it should return true. So that will be for program A. Okay. We'll move on to the next question. Next question is for program B. Program B is simple to see. However, some of the numbers are a bit tricky. Okay. So now let us evaluate program B. For program B, let's create our program environment here. And in our program environment, let's put the declarations. First of all, we will have the z, y, and x. Z is initially set as 1, y as 1, and x as 1. Then we will have a function goo. Function goo is basically just a function object here. So let's create the function object. Whose parameter is f, and the body, well, I don't need to write this. So that will be my goo. And then I will have my who. My who here is basically the result of applying goo to this lambda expression. Okay, but then that's what we discussed in the studio session. Before this lambda expression is passed on as the function f, it has to be evaluated first, so the function object has to be created in the program environment. So before passing it to f, you should create this lambda expression, and hence I will create a lambda expression here. That will point to my program environment. Okay, this lambda expression is basically my y becomes 10 times y plus z. So y becomes my 10 times y plus c, something like this. For simplicity, I'll not write the param and the body. Okay. Now my constant who will basically become the result of my GU to this lambda expression. So now I have to evaluate the GU. When I evaluate the GU, I will extend a frame. Where do I extend? I will have to extend from the program environment, since this arrow of GU, it points back to my program environment. So my GU will be created here. And inside here, I will have the parameter that will be my f. I think the box is too big. So my f now will simply be this lambda expression. Okay, my f will be this lambda expression. And inside now, I will be creating another frame. This will be for the function body. The function body itself, it will have a y is 2, x is 2, but then you will set your z as 2. Your z now, it will set from your program environment. Okay, since it's not creating a new binding here. Then you have a new g. This g will basically be a function object, since it's a lambda expression. So it will refer to a function object that's created here. Okay, since you create it inside this function body, so it will point back to the function body. Then your z, you update this at you update the z as 3, you update your y as 3, and your x as 3. Then you return g. So if you return g, right, basically your who now, your who will be referring to this function object. Since you are returning this function object, so the result of applying GU y to 10 times y plus c would be this function object. And that will be it for who. Okay. Once we finish the who, we will now evaluate the z is equal to 4, y is equal to 4, and x is equal to 4. So let us update. Since they are located in the program environment, we are now currently in the program environment, so we update the values here. Once we update the value, we will create another constant w. That is the result of applying who to a nullary function. Okay, who now points to this g. So we are evaluating this function object. Since we are evaluating this function object, right? But then we don't have any parameters and there is nothing in the body here. There's no bindings inside the body. So we don't have to extend the frame from the body of GU. We don't have to do this. Okay. So instead, we're just gonna evaluate. Okay. So we are going to evaluate here. When we call who, that's going to call this part. It will now call 100 times x. Okay. Now you are currently in this environment. Which x should we invoke? 3 or 4? Okay. So from this function object, you move to this environment, then you see an x. So in this case, you will take the x as 3 instead of 4. Okay, so now my x will be 3. Then this will be 100 times 3 plus f of y. F of y, right? So basically, I will be evaluating f, but then my parameter y would be, is it 4 or 3? Should be 3, because that's the one that you found, okay? F of y, the nearest y to this point is basically your y occurrence here. So that will be your y. Then you will apply f of y. So f is located in the program environment. Since it's located in the program environment, when evaluating f of y, it should extend from program environment. So I'm going to create a new frame here to evaluate f of y. When I evaluate f of y, my y is 3. So I apply the parameter y becomes 3. And then I return 10 times y plus c. Now I am currently in this environment. Which y should I take? Which z should I take? Obviously, I will take this y. However, the z now, instead of accessing the previous one, I will have to go to the program environment, then I will see that I will take this z as 4. So in this case, I will return 10 times 3 plus 4. That will be returning 34. So upon finishing this, my constant w would be 100 times 3 plus 34. That will give me my 334. So that is the result of program B. And obviously you can see how many frames and how many function objects are created after finishing this evaluation. Okay, then that will be it for program B. Now we'll move on to program C. For program C, it's a bit more complicated now because there are some nested functions. So first of all, let us create the functions here. Say now we have our mu, then we have the L and the R. So I'll create something like this. Okay, so my mu is a function. Then my L is a list. Then my R is the result of applying mu with this lambda expression and L. As usual, since we are passing a lambda expression into a function, so this lambda expression has to be evaluated first in the environment of the program. Okay, so once it's created, we will have to create this first. So let's create one. Say this thing. So this would be, it takes in a W and then returns 10 times W. Okay, returns 10 times W. Then now we are going to evaluate the mu. To evaluate the mu, we will now extend the frame from the program environment. So the parameter will be f and xs. F would now be referring to this lambda expression, of course. Okay, since this f refers to this lambda expression, so it should point here. Now my xs should point to L, so I'll point it here. Something like this. Or perhaps I can draw something better, I think. Or perhaps with another color. Yeah, like this. This will be my xs. Okay. Now inside here, inside my body, I have another function. So I will need to create another declaration. Inside here, I will create my function called d. So this d is a function. It will create a function object. Okay. And now I will need to invoke d on the parameters f and xs. So my d now, it will take in a g and ys, right? So technically, I will need to draw another frame for g and ys. G will have to point to the same function object as f, and ys will be pointing to the same list as your xs. Okay, we'll point here. Now after doing this, you will check since ys is not null, you will have to return a pair that contains g of head of ys and mu g tail ys. Okay, g is here. So when you call g of head of ys, you have to extend the program environment also. Say here I will need to evaluate the g of head of ys. So say g of head of ys, that will be head of this list, so that will be g of 1. When I call g of 1, my g now takes in a w as 1, and then it returns 10 times 1, that will be returning 10. So this whole thing Once I finish evaluating this, it will return me a pair whose head is 1, whose head is 10, and the tail will connect to mu of g tail ys. Okay, so now I'm gonna repeat the same thing, but for the tail of xs. Okay, the tail of ys, I mean, which is still the same thing. So now I will need to call mu g tail ys. So when I call mu, my parameter of f would still be this function. Then my parameter of xs would be, yes, the tail of this list. Okay, so the tail of this list, and then inside here, I will need to create another frame for the body. However, here's the catch. Your function d is redeclared inside the body here. So by right, you will have to create another declaration for d. That will mean creating another function object. Okay, although they seem the same, however, it's created in a different environment, so you have to make another declaration. Afterwards, you will be creating another g and ys also. Okay, and then now your g will still point to the same function. Your ys will still point to this tail here. Then what do you return? You return a pair where g head ys and mu g tail ys. Okay, so by the pattern now you will see, you will eventually call another g, but on 2. Okay, you'll be calling it here. So now my g would be g of 2, my w would be 2, and then I return 20. Okay, so something like this. Then I will need to create another frame. So now you can see a pattern already. It will be another the same thing. Okay, for f and xs, then for d, then d will create the function object, then another one for g and ys, and then afterwards I need to call this with w is equal to 3. Okay, so for simplicity I will just put it like this. Then there will be another d, we'll create a function also, then another g, ys, then my w is 3. Okay, then this will be 30. However, now your tail of ys now would be null. So when this is null, you will still have to execute the move. When you execute this move, your elf will be the same. However, your access now would be null. Okay, your access is null, but then in here, you will still have to evaluate your d also. So there will be another d. Then there will be another function object also. And in here, you will still have to extend one more for your g and ys. But now your ys will be null. And since your ys is null, you will just need to return ys that is returning null. So this will be your null. And by now, that would be the complete environment model. But of course, don't forget to connect your R to the result of applying everything. That is connecting your R to this resulting pair. Okay. So now you can see that instead of having to draw everything correctly, right, as long as I can see the pattern, then that will be it. Instead of having to evaluate each of them one by one. So now you can see that the frames, it's 3 times 4, that will be 12, plus this 3, plus the program environment, so the total frames will be 16. Okay, then the number of pairs created, that will be 1, 2, 3, 4, 5, 6. Then number of function objects, you can see 4 plus 2, that will be 6. Okay, so this will be the environment model. Okay, and now finally we'll move on to program D, which is the last and I think a more tedious one. Although in this case, I will also not be drawing the complete one, since it's quite long to draw everything as a complete one. Okay, but now let's discuss. So for the last question, we have two functions in the program environment. So let's draw this. In the program environment, I have a Q and I have a C. It needs to be. Okay. I have a Q, I have a C, then I have an AA. This Q refers to a function object. This C will also refer to a function object. This AA now will refer to an array. However, this array will be from 1, 2, 3, and 4. Okay, this will be my AA. Now let's see. We are going to apply QCAA. QCAA. Do I need to evaluate C first before moving on to Q? Technically, yeah. However, your C is already evaluated. So once I call QCAA, right, I will have to extend from the program environment. But now my fun can just directly refer to the fun of this thing. I can refer to C directly. And also my A, I can refer this to my array. That will be the parameters for QCAA. Okay, this will be my QCAA. After I call QCAA, then inside here I will have some decorations. That is my len. My len, I will have my len as 4. Since array length is a primitive function, so I can just put the primitive value here. Then my m as 0. So while m is less than len, I will have to evaluate this. But then since there are no decorations inside, so I don't need to extend any frames. Okay. It says that position m in array A will be equal to fun am am. So now I'll be calling fun on am and am. So fun is basically C. So if I'm calling C, then I'll have to extend the program environment also. So this is basically C, but now my m is still 0, so that's C A0 A0. A0 is basically 1, right? So I put it as C11. Hence my A would now be 1 and my N would be 1. Okay. Now my A is 1, N is 1. Then inside here there is another decoration that is basically for ACC and for I. So ACC is, let ACC be 0 and I is 0. Then while I is less than N, which is correct in this case, then I'll need to create another one. So in here, sum would be ACC plus A, there will be 0 plus 1, there will be 1. Okay. Then ACC is equal to sum, so I update this as sum. I is equal to I plus 1. By now, 1 is not less than 1, so the loop breaks here. Okay. So at this point, it returns ACC. So now my A0 should be set as my ACC, that will be 1. So I'll set this as 1. Okay. Then I will need to iterate through my m. So m is equal to m plus 1. Okay. Now since my m is still less than the len, I will need to create another frame to calculate C of A1 and A1. A1 and A1 means that my A now will be 2 and N will be 2. Then I'll have my ACC. My ACC and I, they are all set to 0. I also 0. So now while I is less than N, I will need to create another sum here. Sum here would be is equal to ACC plus A, that will be 2. And then ACC is equal to sum, I is equal to I plus 1. But since 1 is still less than 2, I'll need to create another frame here. Now my sum would be ACC plus A, 2 plus 2, that will be 4. 2 plus 2, that will be 4. And then now my ACC will be 4. Then my I will be 2. Now the loop breaks, so now my 2 will become 4. Once you see the pattern, right, this should be easy already. So what this does is basically it will sum your a plus a plus a plus a n times. Okay, so basically it will update your a, so a plus a plus a plus a n times, that's what it returns. Okay, so now let's move on. We'll move on to iterating the m to 2. Now a2 will be 3, so this will be my c of 3 comma 3. Now my a is 3, then my n is 3, and here I will need to extend another one for acc also. Now you'll see the magic. acc now would be 0, I would be 0, and here I will have another sum. So my first sum would be 0 plus 3, that's 3. Update this as 3, update as 1. My other sum would be 6, and my other sum would be 9. I'm too lazy to draw the arrows, but you know what I mean. So now you return 9. Okay, now you return 9 here. And finally for 4, you're gonna iterate this again. So now we'll get another one for 4. I'll draw another here. Now my a will be 4 and n will be 4. Then I'll have an acc again. My acc now would be 0. My I would be 0. So now my sums now, I will have sum is equal to 4, sum is equal to 8, sum is equal to 12, and sum is equal to 16. All of this will extend from here. Now my ACC will be updated to 16, this will be 4. I'm skipping some steps because, of course, RA is only 45 minutes, so it's impossible for you to draw it completely. Okay, so now your 4 will be updated to 16. And now your M would be 4. And once your M is 4, the loop breaks. And that would be your final point of cool. Afterwards, you're just gonna display your AA, so that means you're gonna display this array 1, 4, 9, and 16. Okay, so what if you have something like, say the array is like 10 elements, but then the same thing here. So instead of having to draw them one by one, you can now see a pattern. For each of these, you're basically adding 2 frames on the top here, plus 1, plus 2, plus 3, plus 4, and so on and so forth. Okay, so how many frames? How many frames can simply we get as this is basically like an arithmetic progression. This is 3, 4, 5, 6 frames and so on and so forth. So that'll be like 2 plus 3 plus 4 plus 5 plus 6 plus 1 frame for the program environment. That will give me something like this will be 20 plus 1, that will be 21 frames. Okay, so that will be it for this reading assessment 21-22. If you have any questions, feel free to consult me anytime. All the best.